Hello everybody, it's your wonderful, most favoritist math teacher video from Mr. Martin. Oh yeah, it's that time of day, it's math time. Yep, time for math, time for specifically trigonometry. Trigonometry, yeah. How's everybody's day going? Pretty good? Yeah? Solid? Maybe? Yeah, just like Dora the Explorer, I ask you questions that you can't answer, or you can, but I can't hear, and then I assume you're giving me the best answer in the world. So yeah, I'm glad you're having a great day. I hope it keeps up. It's about 10:30 here. I'm sorry I'm uploading this video late. It's been a very crazy week. You guys will find out why later on down the air. So let's get to it then. Trigonometry. What is trigonometry? Honestly, it's just a fancy way of let me put it this way. If I have a triangle, any sort of triangle, and I know an angle and two of the sides, I can figure out this side no matter what. Just think about this really quick. Let me draw a better triangle. If I have this triangle and it's say this angle is 105 degrees, and say this is 10 and this is 6. This is a 10, not a 16, right? That's a fixed. These sides aren't going to move because the angles there is fixed and their length is fixed. So it's a super fixed figure or shape. And then if I connect this, that side has to be a certain measure. And trigonometry is how you find those lengths within a triangle. So trigonometry is using angles, using side lengths of triangles to figure it all out, to figure out those sides. Now, the easiest type of trigonometry that we know is called right triangle trigonometry, and that's what we've been doing this whole time with number 1 and 2 is using right triangles, using specifically the Pythagorean theorem. So I'm also going to, by the way, I'm going to post a video. I'm not going to go in too deep into it because I think I looked at some videos. There's some better people who do a better job explaining where trigonometry comes from, and I'll link a video to that. It's pretty cool. Maybe I'll make my own, but I'd have to think about it more. This is mainly for the homework. So first things I want to talk about is the easy form of trigonometry is called right triangle trigonometry. So if I have a right triangle, normally what we've been doing is we've been saying, hey, if I have 5 and 4, I can figure out this by doing the Pythagorean theorem, and that works. But in right triangle trigonometry, it says, hey, if you don't know these, there's still ways to solve a problem. For example, if I only know this side and this angle, I can still figure out all the other sides. And that's where it's going to. But let's backtrack a little bit. Let's just talk about what you're going to need to know. And there are these things called the trigonometric ratios. And that is specifically sine, cosine, and tangent. Get used to memorizing these. Sine, cosine, tangent. Written short as, it looks like sin. It is not sin. We just still say sine. So no, you're not committing a sin when you write this out. And then cosine is just written cos, but cosine, and tangent is just written tangent, right? And those are the three operations that we use in trigonometry that we're going to be using at least in this homework. And what they are is they're a representation of what's going on in the triangle. So the sine is the ratio. The operation of sine is the ratio of the leg opposite the angle and the hypotenuse. Now, let me just preface this and say this is going to be really confusing at first because it feels like we just kind of drop this on you guys and you don't know where it comes from. And I know in math you need to know where something comes from in order to better understand it. But knowing where it comes from takes pre-calculus and calculus type of math. So we're not going to do that. So just hang on and try and just roll with it as best you can. And also what I'm going to preface is that when you do sine of something, you're not saying sine times a right here. So it's not multiplication, it's not division, it's not addition, it's not subtraction when you do sine, cosine, or tangent. It's its own unique operation, and I'll go further into that. So let me go back to that page, and I'll get into it. Okay, so let me erase this. If I have a triangle, been a long time getting there. If I have a triangle, specifically a right triangle, this is a right angle. Let's label the sides first. This is the hypotenuse. Hypotenuse. Okay? And then I have the right angle, and then these are the two legs, right? And then this is an angle, and this is an angle. Now, let's say I only know one angle. Let's say I know this angle. We're going to call it theta. They call that, this little like circle with a line through it, they call that theta. Okay, that's theta. Let's just write it up here. They call that theta. It's just a Greek symbol. Not a really big deal. Don't need to remember that. But now what they say is that if you can take, and the other thing I want to mention is you always take the sine or the cosine or the tangent of an angle. So how they write it is you take sine of theta or sine of an angle, and that equals a ratio. So the sine of an angle or a theta equals a ratio. Now, specifically, the sine is equal to the opposite side over the hypotenuse. So if we're talking this is theta, the opposite side would be here. This is the opposite side. I wrote that sideways so you can press. So the sine would be, if this had a value of 6 and this had a value of 10, the sine of theta in this case would be 6 over 10. And again, I know it's just kind of like, whoa, you're probably thinking, whoa, like this is confusing. Like, how does a sine of an angle, like I don't even know what the sine is, and how does it equal the ratio of two sides? I know. We didn't even, like, they don't even explain it. They just expect you to just like pick it up on the fly, and I know it's frustrating. So let me just show you some problems when we get there. And yeah. So the sine is the hypotenuse opposite over a hypotenuse. And the cosine of theta is written as the adjacent over hypotenuse. And so what that means is if this angle is like, if this side is x, then the cosine of theta would be the adjacent side x over the hypotenuse. And so that's what they're talking about with the cosine. And then the last one you need to know, and I'll go into this again, is the tangent. So if I have the tangent of theta, the ratio for the tangent of theta is the opposite over the adjacent side. They write that OPP and HADG. Okay. And that would be 6 over x. Because I take the opposite side and I put it over the tangent, the adjacent side. Okay, moving on. Let's go back to this little thing. So they write these out here. The ratio of the sine is the ratio of the leg opposite to the angle to the hypotenuse. So the sine of A, so if I take the sine of this angle right here, I would do the opposite over the hypotenuse. So it would be A over C. Right? Because I would do the opposite of A, the angle, the side opposite A, and then over the hypotenuse. The hypotenuse is always the longest side. And if I take the sine of angle B, this one, I would do the opposite side, B, over the hypotenuse C. So it's going to be B over C. Okay? Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Okay, so if I take the cosine of A, I don't do the opposite. I do the side, the leg adjacent. So this is B. Not this one, because that's the hypotenuse, but this one. So I'd have B over C. And then the cosine of B, I would take the leg adjacent, so not C, because that's not a leg, that's the hypotenuse, but A, and I do A over C. So I'd have A over C, right? Tangent is the ratio of the leg opposite of the angle and to the leg adjacent of the angle. So the tangent of A would be A over B, because you do the opposite side first, divided by the leg adjacent. So B, not C, because C is not a leg. So I would do tangent of A is A over B. And then if I have tangent of B, it'd be the opposite, where I do the opposite side first, B, over the leg adjacent, A. B over A. And that's it. Okay. Now there's a fun little acronym to help you remember all these opposite and hypotenuse and all this stuff, the ratios, and it's called SOHCAHTOA. Oops. Or as I remember it, SOHCAHTOA. So SOH, sine is equal to the opposite over hypotenuse. SOHCA, cosine is equal to the adjacent over the hypotenuse, and then TOA, SOHCAHTOA, or just SOHCAHTOA as I always called it. Tangent is equal to the opposite over the adjacent. So tangent, or sine, is equal to the opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse. And then tangent is equal to the opposite over the adjacent. And there you go. So you're probably still really confused. Let's do some problems, and I think hopefully this will help you out a little bit. Give each trigonometric ratio as a fraction in simplest form, right? So if I take the sine of A, the sine of angle A, and then I need to do the opposite, so I go opposite of A, and that's 5. Over, so I'd have 5 over, and then I do the hypotenuse. The hypotenuse is always the longest side over 13. That is it. Cosine of A. So cosine of A would be the adjacent side, so I'd take the adjacent side, so 12 over the hypotenuse 13. Tangent. The tangent side, the tangent is of A would be the opposite over adjacent. So the opposite is 5 over the adjacent is 12. So I'd have 5 over 12. Sine of, then moving on, sine of C would be opposite, which is 12 over hypotenuse, which is 13. So 12 over 13. And then I would do cosine of C. So cosine of C would be adjacent over hypotenuse. So I do 5 over 13. Tangent of C would be the opposite over adjacent, so 12 over 5. So really what these trigonometric properties are, or these trigonometric operations are, is you take the sine or the cosine or the tangent of an angle and it equals a ratio of sides within a right triangle. And that's really what we're doing, especially for homework 1. And you can do like the rest of these, and you can make it happen. Let's actually do some of your homework problems. Awesome. Okay. So actually, yeah. So number one, right? We just kind of did. We just kind of did with the example. So sine of q, right here, would be 14 over 15. So I would do 14 over 50. Sorry, and it's 14 over 50 because I do the opposite over the hypotenuse. And then simplify that because they want it in simplest form. It'd be 7 over 25. Divide each one by 2. The cosine of q would be the adjacent, so PQ, let's just call this side x, PQ over 50. X over 50. Okay, and that's the adjacent over the hypotenuse. The tangent of this angle would be the opposite over the adjacent, so 14 over x. And there you go. And then you do the same with sine of r, cosine of r, and tangent of r. I'll let you guys do that one. Alright, so now we get to the part we actually get to solve for x. So now this is where you get to use your fancy-dancy scientifico calculator. So let me actually look at one. Scientific calculator. Alright, now you notice when you look up scientific calculators, or you should have one at home, there's these like sine, cosine, tangent buttons right here. Right? Those are what we're working with. So when I say you take the sine of an angle, you can actually plug it into your calculator. So if and this is what these problems are, they all give you one angle. Like here's 29, 48, 67. Take the sine, cosine, or tangent of an angle, and then you can plug it into your calculator. But now here's the thing. If I take, say I take the sine of an angle. Oops, I need to switch. I take the sine of 48. What's the sine of 48 going to equal? And it equals the ratio of sides. So in this case, it's going to equal the opposite side, x, over the hypotenuse. Do we know the hypotenuse? No, it's going to be x over, we don't even know it. So this doesn't work. We want the 17 to be included. So don't use sine. You have to figure out which right operation you're going to use. So in relative to 48, we have the opposite and we have the adjacent side. So we're going to need to do, not sine, sorry, but we're going to need to use the one that uses the opposite and adjacent ratio. So if I go way back up to here, which one has the opposite and adjacent ratio? Tangent. So I'm going to use tangent of 48. So I'm going to go, in here I'm going to press tangent of 48, and that's going to equal x opposite over adjacent 17. Now here's where the next part is. Because we've never worked with this operation, go to your scientific calculator, do tangent of 48, in parentheses, press equal. You'll get a weird decimal. Make sure that weird decimal works. Oh, hold on. So this is the other thing that's weird. There's these radians that they use in trigonometry. Make sure you're not on the RAD, you're on the degrees, because you're working with degrees. I can go into that later. It's tough when we're in remote learning. But just make sure in your calculator mode, you're in degrees, not radians. So then we do tangent of 48 again, and we'll get a different answer actually. We'll get 1.11, which makes a lot of difference. I'll show you why. So 1.11. So this equals 1.11, which equals x over 17. Now 1.11 equals this, and now we don't have any sort of weird funky number. We just have a number, and a variable, and we can solve for it, right? So solve for x by multiplying by 17 to each side. 17 times 1.11, 17 times 1.11, We get 18.87. 18.87 equals x. That is your answer. So, it's long story short, it's going to be confusing. You get it down, it becomes a lot simpler. You just got to get that breakthrough. Find that breakthrough, you know? That's really how a lot of math is. So you get to really high math, you just got to find that breakthrough, and it becomes nice. All right, number 3, it's going to be very similar. All these are going to be very similar. Your first step is to find the ratio that uses these two sides. So if I look at this angle, this side is opposite, and this side is the hypotenuse. So if you go back to your little SOHCAHTOA, which one uses opposite and hypotenuse? Well, tangent was the opposite and adjacent. Cosine is the adjacent and hypotenuse, so it's got to be sine opposite over hypotenuse. So I'm going to take the sine of that angle, 67, and it's going to equal x, the opposite, over hypotenuse, 29. So go to your handy dandy scientific calculator, and it's going to be sine of what, 67? 67 equals 0.92. 0.9, oh, not 0.6. 0.92 equals x over 29. So then you're going to get rid of the 29 by multiplying by 29 to each side. So I'm going to have 0.92 times 29. So I'm going to take my answer times 29 equals 26 point, let's round up to 26.69. So x equals 26.69, and that is your answer. Okay. Let's see what else I should make sure you guys are prepared for. Yes, some of these ones. So they throw in some difficult ones at the end. I'll do 12 and 14 for you. Okay, 12 is, here we go. So 12 is like this. Break it up into two different triangles at first. So just like up here where we had these ones, they had one side called x, right? So you can solve for a certain side by labeling it x. So which side would we want to label x? Well, we could label this x and solve for that side, but it wouldn't really help me in this other triangle, would it? So I'm going to label the side that they share x, and I'm going to solve for that side. So if I look at 54, BD is the opposite side, and 20 is the hypotenuse. So I'm going to use sine again, because sine is equal to the opposite over the hypotenuse. So sine of 54 is equal to the opposite, which is just x, over 20. Plug it into your fancy dancy scientific calculator. Sine of 54, right? 54 equals 0.809. So 0.81 equals x over 20. Multiply by 20, multiply by 20, and then so times 20, and I get 16.18. So x equals 16.18. All right, now I have this triangle here, ding, 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 and one side is 16.18, one side, this is 28. Now I need to find DC, so I'm going to label that, let's call it y, and I'm going to have to use another trigonometric ratio to solve for that. So I'm going to take what do I want to do? I want to use the opposite, and I want to use the adjacent So I'm going to use the SOHCAHTOA. I'm going to use the opposite over adjacent, which is TOA tangent. So the tangent of 20 equals the opposite over the adjacent, so 16.18 over the adjacent, which is we're calling y. So then I'm going to plug in tangent of 26. Tangent 26, which is 0.487. So 0.487 equals 16.18 over y. And then I got to get y off the bottom. So what I'm really going to do is I'm going to multiply by y first. And then I'm going to get y 0.487y equals 16.18. Divide by this number now. Divide by the 0.487. And I get y equals, let me do that in the calculator. It's 16.18 divided by, by that, 0.48. 0.47, so 16.18 divided by 0.4877 actually. 33.17. So y equals 33.17. And does that answer make sense? Yeah, if this is 16, this looks like a lot bigger than that. So 33.17. Okay. There we go. Yeah. So what do I want to... Okay, having a little bit of brain fart here. We wanted to do 14, 15. 14 is a word problem. Again, with word problems, especially in geometry, write out a picture and just take the important information. So a wire is attached from the top of a 30-foot telephone pole. Ooh, bam, right there. Let's draw a 30-foot telephone pole. Let's make it red. This telephone pole is 30 feet tall. And it is attached from the top of a 30-foot telephone pole to the stake in the ground. So if the angle formed by the wire, so here's a wire, let's make it green. And if this angle is 40, the angle formed by the wire and the pole, actually, so this angle is 48. What is the length of the wire? So they don't want this, don't worry about that. They want to know the length of the wire, this right here. So let's call that x. So I have an angle, I have a side, and I have a side. So this side right here is adjacent, and this side is the hypotenuse. So I'm going to use this operation that uses the adjacent and the hypotenuse. It's not SOHCA, it's not sine, because sine uses the opposite. It's cosine. Cosine is adjacent over hypotenuse. So I'm going to take the cosine of 48 degrees, and that's going to equal 30 over x. 30, I said, not 36. So cosine of 48. Cosine 48 equals 0.669. So 0.669 equals 30 over x. Now I'm going to do that whole thing. Here's a little trick when you encounter these problems. Just switch the x and the 0.669. It's a little trick. So I'm going to say x equals 30 over 0.669. Because what happens is you end up multiplying by the x, and then you end up dividing by the 0.669. So that's how they just switch, essentially. And then you do that. 30 divided by 0.669. 30 divided by 0.669. Equals 44.84. So x equals 44.84. And there's your answer. Which makes about sense because it would definitely be longer than the pole. So, yeah. Alright. So there we go. There's a lot more to trigonometry. I just want to get you the basics so you can like crash course through this this homework. And then I really wish we were not in this remote learning. There's so many cool things about trigonometry that make it fun. and remote learning, it's probably not going to be that fun. But let's do it. Let's get through it. Yeah, I do want to write one little step. So hang in there. So steps to solving these problems. If I have a triangle, say I have an angle and it's like 38, right? Your first step is to determine which operation uses the sides given, or the sides you need, given / needed. So if I have like this side's x and this side is like 5, obviously I don't want to use the operation that involves the hypotenuse, so you would say I need to determine which operation uses these two sides. And I would start by just write out which side is which. This is the opposite, this is the adjacent, this is the hypotenuse. So I need the opposite and the adjacent. Well, which operation uses those? It's going to be the tangent, right? So you would figure that out. In this case, it's the tangent. So I would take the tangent of 38, which leads me to my next step, set up an equation. This one is, sorry, that looks weird, 5, x over 5. So the next step is to set up equation. Number 3, the third step is to plug into your calculator, because you have to use your calculator actually. And if you don't have a scientific calculator, just Google scientific calculator. Plug in to calculator. Specifically plug in that trigonometric operation. And then lastly, solve for variable. Whatever variable it is. Could be x, could be whatever. Okay, solve for the variable. And determine which operation uses the sides given, set up equation, plug in the calculator, solve for the variable. There it is. Okay, you may not fully understand where the tangent or the sine or the cosine comes from, but sometimes you just gotta like roll with it and say, hey, this is what I can use to solve the problem. So let's use it, even though I don't know where they come from. So I will post a video that shows where they come from. Feel free to watch it. But yeah, there's homework number 3. Please send questions if you're stuck. Don't sit there and give up or like spend an hour on it. Just send it to me, and I can either make another video or like show you my work or show you the corrected work and just send that to you, right? Yeah, and obviously please don't just Google the answer either. It's not going to help you in the long run. You guys are doing great. Hang in there. We're almost there. See you guys later. Have a great day.